Okay guys, Boston 25 here watching the launch of OSIRIS-REX atop an Atlas 5411 from Cape Canaveral, Florida. There is sound on, yeah? Just gonna check that. No there isn't.
Of OSIRIS-REX, the origins, spectral interpretation, resource identification, security regolith explorer spacecraft. This is Atlas launch control, and we're just under T-minus 1 hour, 20 minutes, and counting. Liftoff is targeted for 7:05 p.m. Eastern Time, the opening of a 1 hour, 55-minute launch window. There are multiple launch opportunities, one at the beginning of the window and then others that are spaced 5 minutes apart throughout the launch window should they be needed. But everything technically is going well. Weather is now 90% go. There's a 90% chance of favorable weather for launch with just a slight chance of violating the cumulus cloud rule. OSIRIS-REX is going to be boosted atop this United Launch Alliance Atlas V rocket in the 411 configuration, and that is a unique configuration in that the Atlas booster and the Centaur upper stage are joined by one strap-on solid rocket booster to provide the additional thrust needed to boost the rocket and place the spacecraft in the proper vicinity in space. The launch team here at the Atlas Spaceflight Operations Center has been on console since about 3 o'clock Eastern Time. Operations began about 30 minutes ago to fill the Atlas booster and the Centaur upper stage with liquid oxygen. The tanks are expected to reach flight level at about T-minus 5 minutes, which is about a minute before entering our planned 15-minute built-in hold at T-minus 4 minutes. Liquid hydrogen will be loaded into the Centaur tank at about T-minus 16 minutes. The Atlas previously was fueled with RP-1, a rocket-grade kerosene, and all fueling operations have been proceeding normally. Today begins NASA's first mission to take a sample from an asteroid and return it to the Earth. The mission will help scientists investigate how planets formed and how life began, as well as improve our understanding of asteroids that someday could impact the Earth. The OSIRIS-REX spacecraft will travel to the near-Earth asteroid Bennu and bring a sample back to Earth for intensive study as part of NASA's quest to study our solar system and beyond, to better understand the universe and our place in it. As we watch right now, the 4,650-pound fully fueled OSIRIS-REX spacecraft will begin a 7-year journey, reaching the asteroid target Bennu in the year 2018. And after a survey of the asteroid to characterize it and locate the most promising sample sites, OSIRIS-REX will collect a sample of surface material with its robotic arm and then return the sample to Earth via a detachable capsule in 2023. Literally, Bennu is a time capsule from the earliest stages of the solar system's formation. The material that is contained within the sample returned to Earth will provide important clues to the origin of life on Earth and the potential distribution of life elsewhere in the solar system. A multifaceted group has worked for more than 5 years to bring the spacecraft and rocket together for today's launch. The mission was chosen on May 25, 2011. Goddard Space Flight Center in Greenbelt, Maryland provides overall mission management, systems engineering, and the safety and mission assurance for OSIRIS-REX. The University of Arizona leads the science team and observation planning and processing. Dante Loretta of the University of Arizona Tucson is the principal investigator. Lockheed Martin Space Systems built the spacecraft. OSIRIS-REX is the third mission in NASA's New Frontiers program, joining New Horizons and Juno. NASA's Marshall Space Flight Center in Huntsville, Alabama manages the agency's New Frontiers program for the Science Mission Directorate in Washington. And launch management is conducted by the Launch Services Program at Kennedy Space Center in Florida. And this launch vehicle you're looking at right now, provided by United Launch Alliance. All that work culminates today with the planned liftoff of Atlas and OSIRIS-REX a little bit more than an hour from now at 7:05 p.m. Eastern Time. This is Atlas Launch Control.
At 470 Centaur LO2 at flight level.
Roger.
Control, T-minus 1 hour, and you were looking at animation of the asteroid Bennu, 492 meters in diameter, traveling 63,000 miles an hour and orbiting the sun every 1.2 years. That is our target for the beginning of the Atlas launch today. And we're pleased to be joined at this time by Dante Loretta, Principal Investigator from the University of Arizona at Tucson. Thank you for joining us.
It's a great day. Glad to be here.
You know, we were thinking 50 years ago today at 8 p.m., which is almost to the second the time that your spacecraft is going to be deployed from the Atlas Centaur. The very first episode of Star Trek, the television series, aired on network television. And I just kind of wondered whether or not Star Trek or any other science fiction might have drawn you into what ultimately became your career.
Absolutely. I've been a huge science fiction fan ever since I was a little kid. I started reading the classics, H.G. Wells and Jules Verne when I was in elementary school, moving on to Arthur C. Clarke, Ray Bradbury. For Star Trek, I was definitely a Next Generation kid that came out when I was in high school. Big fan of Captain Picard and crew as they explored the galaxy.
So science fiction becomes science reality.
Oh, it's a dream come true. I have to keep pinching myself to make sure this is all real.
Well, the whole idea of launching a spacecraft toward an asteroid and then actually making contact with it and bringing a sample back to Earth it's audacious and it's amazing. What prompted that idea?
It really follows on the science that I've been involved with my whole career. I study the origin of the solar system and particularly focused on the origin of life and the why is Earth a habitable planet. And we can really only answer those questions by bringing samples back into our laboratories.
That's great. Well, we're really, really excited about it. And understand that you have a video that we'd like to play, and you can explain that for us.
Great, let's do it.
All right.
So OSIRIS-REX is an awesome acronym that describes the principal science objectives of our program. The first letter of the acronym is the O. That stands for our origins investigation. We also, for origins, we're really going back to the dawn of our solar system. Before we had planets, before we had the sun, we were a giant cloud of rotating gas and dust. Inside that cloud, solid materials started to condense and grow into larger planetesimals, ultimately, in many cases, into the planets like the Earth, out in the outer solar system, the gas giants and the ice giants. Some areas of this early solar system had key organic materials and ices that accreted, and we think that was really critical for establishing the habitability of our planet, because we know by looking at the lunar cratering record that Earth went through a period of late heavy bombardment where thousands of asteroids were crashing into the surface. So to address the questions of how did the Earth recover from that event, we really need to look to sample return. And OSIRIS-REX is following on the footsteps of successful missions like the Stardust Comet Dust Sample Return, which you see some of the footage from rolling by here. And in fact, we're reflying the sample return capsule design from that great mission. And we need to get these materials into our laboratories because the kinds of questions that we're asking are really dealing with trace components in these solid materials. In some cases, we're literally talking about analyzing molecules that are present at the part per million level. And you just can't build an instrument on a spacecraft to make that kind of measurement. Not only that, but sample return really is the gift that keeps on giving. We're going to be able to address our science questions, but generations into the future are going to have access to this material. They're going to be asking their own questions. The next part of our mission acronym is the spectral interpretation. And we've been really fortunate with this mission in preparing to get out to the asteroid, to get access to some of the greatest telescopes on Earth and in space. And we're going to be able to ground truth that information with the science instruments that we're carrying right now. Here you can see the OVIRS visible and infrared spectrometer. This was built at the Goddard Space Flight Center. And this is going to give us information about the mineral composition on the asteroid surface. We are complementing that with the OSIRIS-REX thermal emission spectrometer built by our colleagues at Arizona State University. And combined, these two instruments cover a fantastic wavelength range from visible light way out into the mid-infrared. One of our key measurements is to look for signs of organic molecules on the surface of the asteroid to guide our sample site selection. The next part of our acronym we call a resource identification. And we're really thinking back to that sci-fi theme here, and maybe one day getting out to these asteroids and using the resources to further space exploration. And we're going to greatly contribute to that vision because we are going to perfect the operational procedures for how you maneuver a spacecraft around a small microgravity body like Bennu. We're going to map the distribution of minerals and compounds on its surface, in our case to satisfy our science objectives of finding the right sample site, but anybody that wants to get out to one of these bodies for resources is going to need that same kind of technology. Also, when we think about near-Earth asteroids, in addition to the scientific investigations, we do worry about the security aspect. And by virtue of our mission design, we're going to an asteroid that has a reasonable chance of intersecting the Earth at some point in the future. If we want to know precisely where it's going to be, we need to account for a phenomenon called the Yarkovsky effect. And the Yarkovsky effect basically is the absorption of solar radiation and the emission of heat that acts like a thruster and actually changes the trajectory of the asteroid beyond what Kepler's laws would predict. So if you want to know where it's going to be in the future, and we do with this object, then you've got to have this part of the equation. And we're going to measure that very precisely with our mission. The final part of our acronym is the resource identification component. The regolith explorer. Regolith is what we call the loose blanket of gravel and dust on the surface of these airless bodies. And we're really interested in the geologic processes that occur on a small body like Bennu. It really behaves very differently than we would think living on the 1G environment at the surface of the Earth. We're going to send a spacecraft down to make contact with that surface to collect our sample, and that's the prime science objective of the mission. But just the act of doing that is of itself a great science experiment because we're going to see how the surface of the asteroid responds. We're going to gain a lot of information about how those regolith grains act in that environment.
That's very, very exciting stuff, and you must be quite thrilled. We're about an hour and 20 minutes away from the very beginning of your mission.
This is a dream come true. I've been working on this program for over 12 years since the original concept was laid down. We made the decision to write proposal to NASA for this program. Thousands of people have worked to get us to this point. It's an amazing team. I want them to know how proud I am of all of their efforts. Everybody has been top-notch, fantastic to work with. And I know they're all sending out their hopes and prayers with us as we start this great journey to Bennu and back.
Well, congratulations, and we're all looking forward to it.
Thank you.
Thank you.
Yes.
Due at 50%. Roger.
Atlas Launch Control at T-minus 1 hour, 3 minutes, 16 seconds, and counting. You see the Atlas V rocket poised on the launch pad. Lots of work went into preparing the rocket to put it in place today. One of the final steps was the rollout from the vertical integration facility on its mobile launch platform. The vertical integration facility is about 3 miles south of the launch pad. The roll took about 30 minutes, and the spacecraft was moved to Space Launch Complex 41 launch pad, where it was secured in place and ready for today. Yesterday, United Launch Alliance Public Affairs Representative Lynn Shazine went out to the launch pad right after the rollout, and we'd like to play that for you now.
We're at Space Launch Complex 41, home of ULA's Atlas V rocket. I'm here today with ULA's program manager, Scott Messer. Scott, tell me a little bit about the Atlas V standing behind us.
Well, Lynn, the vehicle standing behind us is the Atlas 411, which means that it has a 4-meter fairing. And although you can't see it from here, it's got a single solid rocket booster on the other side of the vehicle. The vehicle as it stands out here today is about 189 feet tall, which is approximately 1.5 times the height of the Statue of Liberty.
That's almost 20 stories tall. Can you tell me how you moved the Atlas V here to the launch pad?
Yeah, so the Atlas V started this morning down in the vertical integration facility, which is just about 1/3 of a mile down the track here. The team comes in and prepares to roll the mobile launch platform, and then it takes about 30 minutes to roll the platform over to the launch pad. and then about another hour to connect up all of the items that need to be connected at the launch pad, and then we're ready for launch.
Okay, so what next?
So the team will come in and they'll get started. About 12 o'clock, they'll begin the countdown, and around 2:30, they'll begin doing tests of the electrical system and the boxes on the vehicle to make sure everything is in working order. Somewhere right around 5 o'clock, the team will begin fueling the vehicle, and by 7:05, we'll be ready to launch.
Sounds really exciting. What do you think is the most exciting part of your job?
Well, for me, the most exciting part is the last 4 minutes when we go into terminal count. It's a lot of culmination of things getting to this point. There are a lot of activities happening in the last 4 minutes, and it's just very exciting when the launch conductor says liftoff and the vehicle takes off and puts OSIRIS-REX on its path.
Thanks, Scott, for all the great Atlas V info. Did you know that this Atlas V configuration, standing 189 feet tall, is the exact height of Cinderella's castle at Disney's Magic Kingdom? Back to you.
Thank you, Lynn. Fun facts. A beautiful rocket on the launch pad. Once again, the weather is 90% go. The only potential issue today is cumulus clouds, and in a weather briefing that was presented to the launch team a little earlier by 45th Weather Squadron forecaster Clay Flynn, it looks like we really will not have much to worry about today. There's only one cumulus cloud about 45 miles away, and its arrival at the launch pad would be after the beginning of today's launch window. Mentioned, United Launch Alliance is the launch provider for today, with dedicated employees across the country. And for today's launch, United Launch Alliance has dedicated this flight in memory of Michael Drake. Mike Drake studied the moon, meteorites, Mars, Earth, and for the last 7 years of his life was committed to making the OSIRIS-REX mission a reality. He established an international team led by the University of Arizona, along with Goddard Space Flight Center and Lockheed Martin, to propose an asteroid sample return mission to NASA. And he was there leading the celebrations when NASA awarded the mission in May 2011. Although we mourn Mike Drake's passing, he made certain that the mission team was strong and composed of multiple generations to carry on the exciting discoveries far into the future. He continues to inspire us throughout this mission and beyond. This flight is also dedicated to the memory of our colleague and friend Larry Richardson. In his 30-year career in business development at McDonnell Douglas, Boeing, and United Launch Alliance, Larry worked on diverse programs, including the Tomahawk and Harpoon missile programs, the International Space Station, and the Delta and Atlas launch vehicle programs. Prior to his retirement in 2015, Larry led the NASA Civil Space Sales and Marketing team and was instrumental in developing winning Atlas and Delta launch service proposals, including the one for OSIRIS-REX. Larry's disarming personality charmed customers and co-workers alike, and everyone enjoyed working with him. He was a leader, a mentor, and best of all, a friend. And his passing is a great loss to his family and to the United Launch Alliance team. This is Atlas Launch Control at T-minus 56 minutes and counting. And as you can see, standing by, waiting to talk with us at NASA's Goddard Space Flight Center in Greenbelt, Maryland, NASA's Sarah Schlieder. Sarah?
Hi there. We're at the Goddard Visitor Center in Greenbelt, Maryland, where scientists and engineers are coming together along with members of the public and local media to celebrate the launch of this historic mission. I'm joined with Dr. Jim Garvin, Goddard Chief Scientist here at Goddard Space Flight Center. Thank you for joining me, Jim.
Thanks, Sarah. Welcome.
So, OSIRIS-REX is launching tonight on its journey to a near-Earth asteroid, but this isn't the first spacecraft to travel to an asteroid. Can you tell me a little bit about its precursors?
Sure. We've been studying asteroids since the dawn of the space age, but this is the first mission that does three of the great things all in one. Now, we've flown by asteroids on the way to Jupiter and Saturn, seen them up close. We've orbited and rendezvoused with an asteroid, an S-class asteroid, with the Near-Shoemaker mission, exciting mission about 10 or 15 years ago. We've even sent something to collide with an asteroid to see what would happen. And these fantastic missions really set the stage for OSIRIS-REX to bring together the reconnaissance, the going, the touching, the doing the in situ, and then to bring it home. So that's why we're so unbelievably excited, because this is a dramatic extension of anything we've ever done with these priceless small bodies.
Right. You can definitely feel the excitement here tonight. Now, can you tell me a little bit about how OSIRIS-REX differs from those past missions?
So our past missions to asteroids have focused on general reconnaissance of the broad classes of asteroids, the first low-altitude orbits of them to see what makes them tick. And that's great. That's the first phase of exploration. We call it seeking. The next phase would naturally be to go and land or dock with an asteroid and make those measurements. Well, we've leapfrogged that stage with OSIRIS-REX. We've gone to a stage now where we'll not only do the recon spectacularly at the scale of my shoes, but we'll also touch the asteroid, interact with it dynamically to extract samples, and then collect those samples and return them to Earth. That cycle we've never done for one body all in one until OSIRIS-REX. So this is a huge step for humanity. We're going and coming home.
Definitely, definitely. And tell me if I'm wrong, but this is the
You
largest
see Goddard's
sample
rocket
brought
back there.
back since the
A replica of it.
Apollo era?
That's right. This is the first mission, Sarah, the first mission where we've gone to the surface of an object in our solar system and collected samples and returning them. We may get samples as large as some of the bulk samples we collected on the moon in the late 60s and early 70s, which human beings, men and women, brought back for those missions. And we've now
Only men.
changed the game. The robots are doing the work. We're sitting here in Florida or Maryland enjoying the show. And so I have here a little sample of the moon from Apollo 11. Neil Armstrong collected this. Thanks, Neil. This is 200
He's
grams
dead.
of the moon. And if OSIRIS-REX does everything we hope, we will return samples of this magnitude and this importance from this kind of primitive object, a carbon-bearing object. So we will bring back, as we did for the moon, the stories of the history of the solar system in the rocks and soils for the first time since 1972. That's pretty cool.
That's incredible. And now our sample is coming back from a near-Earth asteroid known as Bennu. Why did we choose Bennu, and what are we hoping to find when we analyze the sample?
So Bennu is one of a special class. First, we could see it from Earth-based telescopes in Hawaii and Chile, the Hubble Space Telescope in orbit, even the radio telescopes in Goldstone and other places. So we could map it, and that's important. It gave us information of where it is, where it's going to be, and what it's made of. And we knew that Bennu is a carbon-bearing asteroid, one of a very rare class. So getting to that object, which is also big enough to go encounter in a safe way, was really important. And Dante and his team on OSIRIS-REX have solved the special mathematics to get us there with this robot. So it's special because of what it's made of, its history, where it's located, and the fact that we could see it and figure out all that before we went. We did the recon from Earth and Hubble. So special object for all of us.
Definitely, definitely. Now, take me to the day when we're finally ready to collect that sample. What is going to be going through your head? What is the OSIRIS-REX team going to be thinking? Bring me to that day.
So the team will probably be shaking, tingling in excitement, because this will be the first docking maneuver to acquire something from another object, literally since human beings were on the moon in December of 1972. That's a long time. What was
For the U.S., I think.
planet like in 72? I don't remember, but someone does. In any event, so they will be looking over this mass of high-quality reconnaissance data, which could show you the scale of the tiles in this room, and deciding where they're going to do that first extension of an 11-foot arm for a gentle high five to extract and vacuum. I suspect all of us, especially Dante and the leaders of this team, will be so into it they'll feel the contact as if they were there. It'll be a vicarious experience. For all of us that marvel at engineering, we'll probably be going, oh my God, we can actually do that? And so that's what makes this mission great. The engineering solutions of science problems is always fun. And that's what I think we'll all be saying. And then once we have the sample, yes, we're there. And then, of course, then the long wait to get it home, but the wait's worth it.
Definitely. Jim, for joining us tonight.
Thank you, Sarah. Thank you, Jen. Obviously very excited, as are the people here at Cape Canaveral Air Force Station in Kennedy, Florida, or Kennedy Space Center in Florida, as we are preparing for the launch, targeted for 7:05 p.m. Eastern Time on this Atlas V rocket from Space Launch Complex 41. Weather is 90% go. There are no technical issues being worked. This is Atlas Launch Control.
What's that? I think it might be the movement of the camera, something like that.
Atlas LO2 at 80%.
Roger.
So
CNA-1, pressurize ECB to flight pressure.
Roger.
Atlas Launch Control at T-minus 47 minutes, 17 seconds, and counting. Today's launch will be the 65th Atlas V Evolved Expendable Launch Vehicle flight since the inaugural launch in August of 2002, and the fourth in the Atlas 411 configuration, featuring the 4-meter payload fairing on top, one solid rocket booster attached at the bottom, and a single Centaur upper stage engine. It also will be the very first flight of an Atlas V rocket to an asteroid. You're looking at Space Launch Complex 41, technically part of Kennedy Space Center, and leased to the U.S. Air Force here at Cape Canaveral Air Force Station in Florida. To this point, the launch pad has been used only for non-crew spacecraft, hosting Titan rockets beginning in 1965, and then the Atlas V since 2002. This launch pad has launched many NASA missions to the solar system and beyond, including the Viking robots that landed on Mars, the Voyager spacecraft that toured the outer planets, the New Horizons probe that flew by Pluto, and the Curiosity rover currently traversing Mars. And now a new mission, to launch a mission and a spacecraft to an asteroid. We'd like to show you a video taking a look at the mission and the work that went into preparing for it here at Kennedy Space Center in Florida.
The first spacecraft equipped to take a sample from an asteroid is preparing to lift off from Florida Space Coast in September on a mission vital to unwrapping some of the secrets of mysterious near-Earth objects. Near-Earth objects emit no light of their own, so researchers get few opportunities to study them as they cross through sunlight that reflects their features to instruments on the ground. That's where OSIRIS-REX comes in. Weighing 4,650 pounds and fully fueled, the spacecraft will rocket away from Earth on a path toward an asteroid called Bennu.
OSIRIS-REX is an awesome acronym that captures the primary scientific objectives of our program. The O stands for origins. We're seeking answers to clues to the origin of our planet and to the origin of life. SI is spectral interpretation. Spectroscopy is a technique we use with telescopes and spacecraft instruments to determine the composition of an object's surface. RI is resource identification. We're going to a near-Earth asteroid. We're going to map it with our cameras and our other science instruments to identify the minerals and chemicals that may be on its surface. The S is for security. Because it's a near-Earth asteroid, there is a small likelihood that it may impact the Earth sometime in the 22nd century. And finally, we're a regolith explorer. Regolith is a term for the gravel and dust on the surface of the asteroid, and our prime objective is to explore that material by bringing it back to Earth.
A United Launch Alliance Atlas V has been stacked at Space Launch Complex 41 to start the spacecraft on its way. Standing some 19 stories tall, the rocket with the spacecraft protected inside a payload fairing will fly on a carefully planned course into space.
NASA and LSP have a great history of launching our science missions on Atlas V. It began in 2006, and we have launched 12 critical science missions on this workhorse launch vehicle. OSIRIS-REX will be our 13th mission.
The small spacecraft will go into orbit around the floating rock and carefully survey its surface, relaying the data back to Earth. Scientists will select the best place for the spacecraft to reach out its mechanical arm and tap on the surface to trap dust and material in a tiny canister. Researchers will like to find material from the original formation of the solar system.
The primary objective of OSIRIS-REX is to bring back 16 grams of pristine carbon-rich material from the surface of Bennu. We're really interested in the organic chemistry of these asteroids and the roles these kinds of objects may have played in the origin of life.
OSIRIS-REX will retract its arm and place the canister in a capsule where it will be protected during the ride back to Earth. With its mission done, the spacecraft will fly by our home planet in 2023 and release the capsule holding the asteroid sample. The capsule, protected by a heat shield and equipped with a parachute, is to fall through the atmosphere and be retrieved in the American Southwest.
The OSIRIS-REX mission uses a sample return capsule to bring the material back to the surface of the Earth. We'll land at the Utah Test and Training Range, just to the southwest of Salt Lake City.
From there, researchers will carefully evaluate what's expected to be a couple of ounces of asteroid that could answer some of our most fundamental questions about Earth, the solar system, and the universe. Part of the analysis will include a close look at what was found that may have been picked up on Earth during processing instead of from the asteroid. Planners thought on that, though, and have a step in place they say will prevent confusion.
In this case, we're doing something a little bit different. It's never been done before, called contamination knowledge. We're able to put plates out there where we just have them in the same environment as a spacecraft, and then we'll save them. So in a few years, when the sample comes back, we will have these pristine in storage. When we start analyzing the samples we got back, we can go back and look and see, did we have that? Did we see it on the ground, or did we bring that back from the asteroid?
Teams have been working on the OSIRIS-REX mission for more than 10 years to plan a sample return flight, develop the spacecraft, and get to this point close to launch.
I was involved with the original spacecraft selection process when OSIRIS-REX won that selection, and then we bought the rocket for it in 2013, and I've been integrating that rocket ever since.
The OSIRIS-REX team has worked really hard to make this mission a success, and everybody is very excited and enthusiastic. I can't wait to send this spacecraft on its journey to Bennu and back and begin the next phase of operations.
This is Atlas Launch Control at T-minus 40 minutes, 33 seconds and counting. All the fueling operations have gone perfectly fine today. You can see gaseous oxygen venting from the Atlas V booster as fueling continues. About 55 minutes away from our planned launch today, and at this time we're pleased to be joined by Michael Donnelly, NASA's OSIRIS-REX project manager at NASA's Goddard Space Flight Center. Mike, thank you for joining us.
Oh, thank you for having me here.
How have things been going as we get prepared for the launch of the spacecraft?
Wonderfully. It's been very quiet. I hope it stays that way. We've been having a nice, calm time up there, so
good.
It's all good.
Good, excellent. Well, we have a couple of videos that we would love it if you could explain for us. Start off with...
So here we have the 437th Airlift Wing bringing our spacecraft over here to the shuttle landing facility. And while I have a second, I'd really like to thank them. They gave us a wonderful ride. And while we're on the topic of the U.S. Air Force, the 45th Space Wing has also been just absolutely wonderful hosts. So I want to extend our thanks from the OSIRIS-REX project. So here's the spacecraft in the shipping container. It gets delivered to the Payload Hazardous Support Facility. The next day, it was removed from its shipping container. You can see it right here. It's in its bird cage coming in from the airlock into the high bay. The bird cage is lifted off. You can see the solar array right there. Let's see. There's the crane with its protective canopy right there to keep anything from falling onto the spacecraft. We hook up the lift sling, lift it out of its shipping container, and it'll move over to the spin table. On the spin table, we'll put it into a spin, and we're going to measure the mass and the CG so that we can put in any ballast that might be necessary so that when we fire the thrusters, they go through the center of gravity of the spacecraft. So you can see that operation right here. You can see one of the solar array gimbals right there in that view. So it's being lowered onto the spin table right here.
That's the solar array gimbal he's talking about.
And now she's spinning.
It's amazing the complexity of what goes into making a spacecraft ready to fly into space.
That is true. That is very true. So once the spin was complete, we determined how much ballast we needed to add. We take it off the spin table, then it went over to the spacecraft dolly. From the spacecraft dolly, we're now going to fire the separation nuts that are on both sets of solar arrays so that we can take them off. And this is our pop and catch test that you'll see right here. So pretty soon as it changes frame, if you look at the array, there they went. And so the 3 sep nuts all fire at the same time. We had the lift sling hooked up to the solar array. It'll get pulled off and it'll get put over on its own stand. We did that one day on one array, and then we did the next day we did the other array. The solar arrays will go off and get processed separately. Now the spacecraft's being loaded onto its rotation fixture. From here, this is where we did the bulk of the work at the PHSF. And so we still had a lot of blanket closeouts to do, a lot of blankets to install onto the spacecraft. We had a bunch of instrument inspections to go forth. So there's a nice view of the Plus Z deck right there. You saw the sample return capsule on there. Here you see one of the solar arrays being inspected and cleaned. We're happy to say that none of the cells needed replacing. There's another view of the top deck. The techs here were very meticulous. That right there is a plaque honoring Dr. Michael Drake, who was the original PI who passed away shortly after this mission was awarded. Some blanket work going on. That big round thing there in the front, that's the high gain antenna with its blanket around it. So here's the solar arrays going back on now. As you can tell, this is, highly detailed work, and the Lockheed engineers, they're all outstanding. This was our Hollywood Lights test where we made sure that the solar array cells were all still working, and they were. Once all this work was complete and we did the final inspections, ULA, the rocket manufacturer, they brought in their fairing. You can see the spacecraft over there, and they actually are closing us up in there. So that happened about the last week of August that this operation took place. And then in the early morning hours of August 29th, I believe, we rolled out of the PHSF to go over to the vertical integration facility. And so that was a fun time as well.
Yeah, I can imagine. Spacecraft safely delivered out to the vertical integration facility, and then it was hoisted atop the Atlas Centaur rocket.
It was. It was a good day to do that.
Yeah.
So we found a window where the winds were down, where the clouds allowed us to do it, and it got up there. The ULA guys have all been spectacular as well. Like I said, we've had a really good time here, and we're looking forward to a spectacular launch as well.
Yeah, we are too. I believe there's another video that we have that we'd like to play and ask for your expertise.
Okay, so here we go. The spacecraft separates from the Centaur 59 minutes after launch. 4 minutes later, the solar arrays come out after we've damped the arrays. About 13 minutes after the arrays come out, we've established comm with Canberra, and we know that the spacecraft is safe. 14 days later, we will turn on the instruments and check them out. 1 year later, we come around the sun and we do an Earth gravity assist where we change the plane of the spacecraft to get it into the same orbit plane as Bennu, which is a 6-degree inclination change. 1 year later, in August of 2018, we arrive at Bennu and we'll start all of our remote sensing campaign observations, mapping, everything that is necessary for us to go in and get that sample in July of 2020.
It's a fascinating mission profile, and we really want to thank you for taking the time away from your job to come over and explain this all to us.
Oh, you're quite welcome. Thank you very much. We look forward to it.
This is Atlas Launch Control at T-minus 31 minutes, 9 seconds, and counting. Everything is proceeding normally and headed toward a liftoff at 7:05 p.m. Eastern Time of the OSIRIS-REX spacecraft atop an Atlas V rocket. Crowds have been gathering in expectation of the launch. About 8,000 guests have gathered at Kennedy Space Center and surrounding areas to view the launch of OSIRIS-REX and many more are on the beaches and causeways of the Space Coast. This is a big day for the space community and the Space Coast, and a very big day for NASA. The beginning of a historic mission to an asteroid.
So I just have to take the screenshot.
This is Atlas Launch Control, about 45 minutes away from liftoff today, and we're pleased at this time to be joined by Rex Engelhardt, NASA Mission Manager. Talk with us.
It's my pleasure. Thank you.
This, as we've been talking about, is an extraordinary day for the space program, the beginning of a 7-year mission to an asteroid to gather a sample and bring it back. Everyone we've talked to is very enthusiastic, and we know you are too.
I definitely am, especially with it named after me. So
exactly, that's great. That's a wonderful attribute. Congratulations.
I'll take it.
Well, we have a video that we would like to play and ask if you could help explain, having to do with the flow of the rocket.
Sure thing. What you're looking at on the screen right now is the trucks coming in with the Centaur, which is the second stage of the Atlas vehicle. They're backing it up and moving it into, I think, the ASOC is the facility. And you see they're opening the lid on the container there. They keep it nice and clean as it comes across from Alabama, where they're made, over at Decatur. And then they take it over and do some work on it in another facility, and it'll come back. We'll see some over here in a minute.
So I can't help but laugh as they, driving this the truck at
first stage.
Your average speed.
Coming in now.
No, it's the upper stage, man. The first stage is powered by an audio unit.
Sorry, that was still the second stage over there.
Yeah, this
this is the Mariner. It's the barge that the ULA uses to transport the bigger vehicles, like the first stage, over with. And
it's
so
not a barge, it's powered.
over and move it out from the Mariner and over to that same facility, the ASOC, where they work on it over there, which is where we're sitting now.
I'm sorry, I still find that funny as how they're, just
back the vehicle in. And they'll do a lot of preparatory work and check out of the vehicle, anything that needs to be touched up, since it was manufactured in Alabama.
I'm sorry, I hear ASOC. I immediately think INGSOC.
I think we're heading for the pad now.
Or the VIF. Yep.
Now they've taken it up off the trailer. This is at the vertical integration facility,
or
where ULA stacks it onto the pad. They pick it up with a large crane and move it over to the mobile launch. You can just see the tower on the right-hand side. There is the side of the mobile launch pad
kind
that
of
they use.
behind and rusted.
There's the launch mounts, and they bring it in, gently set it down there.
And then they bring the SRP.
They bring the solid mode over, in high speed, of course, and made it up to the side of the first stage. This gives us a little extra thrust coming off the pad. Made that on the side. You can have multiples of these solid motors. In this case, we're using just one.
Just one.
And then here comes that Centaur. As they said, they process that for a while, and then they've got a new process now where they actually do some of the stacking operations and some of the additional parts that go onto that. They do that work offline. So when they bring it out to the vertical integration facility, it's they can pick it up, and it saves some of the work they used to do in serial. Now it's all done offline. So they picked that Centaur up and up over top of the first stage and made it. We'll see that coming down here in just a second.
Just as with the spacecraft, it's very intricate work.
Very intricate. You don't do anything very fast. That's why they had to fast forward the other one so we could see the whole operation.
And Centaur is on.
And then in just a second, we'll see the crown jewel coming over here. This is OSIRIS-REX
payload
inside
section.
the fairing. They have the nice big OSIRIS-REX logo on the side. ULA has a man that hand paints those logos. He does a beautiful job. And
one man.
The fairing over. We had a rough weather that morning. We were a little bit concerned with some of the storms around and some of the winds that we might see, but it cleared out perfectly for us, and they brought it over, and the winds were calm enough. You'll see when they lift that up, that goes a long ways up, so you don't want any wind blowing it when they do that. So there's strict controls on that, but we had beautiful morning, got it picked up, and they hoisted it up to the top, and you'll see them make that here in just a minute. You can see we were getting a little bit of wind that morning.
You can actually see the little
Slow,
tube there
methodical,
flapping a bit.
careful process.
That kind of describes space business in general.
It does.
And now we have a built vehicle.
We have a vehicle, and it's ready
Sitting
to
on
go.
the pad.
Yeah, that's about a week and a little better than a week ago. And now they finished the processing on it. We'll be ready to launch today.
Excellent. All right, Rex, thank you for coming over.
It was my pleasure. Thank you very much.
Take care.
I think the sun is actually setting, so I'm not sure if this will be a night launch. But either way, it will be damn pretty. Especially if it's a sunset launch, then it's going to look very good.
T-minus 23 minutes, 38 seconds and counting. We still have a planned 15-minute built-in hold that will begin at the T-minus 4-minute mark. Everything continues to go well, technically. Weather remains pristine. There's a 90% chance of go weather for launch today of the OSIRIS-REX spacecraft atop the Atlas V. You're looking at Space Launch Complex 41. Yesterday, NASA Communications' Stephanie Martin was at the pad, and we'd like to play this video for you now.
Thanks. We're here at Space Launch Complex 41. As you can see, OSIRIS-REX is prepared for launch just behind us. The launch pad here will be used for future astronaut missions to the International Space Station, as will SpaceX's Launch Pad 39A, just a few miles north of us. I'm here with NASA's John Cowart from the Commercial Crew Program. John, can you tell us a little bit about the Commercial Crew Program?
Sure. The Commercial Crew Program is enabling private companies like SpaceX and Boeing to take astronauts to low Earth orbit. What this will eventually do is allow them to take anybody who qualifies to go up to low Earth orbit to any station that might be created privately or anything else in low Earth orbit. So it's really enabling a great capability for the United States.
So there's been a lot of work here along the Space Coast to prepare for Commercial Crew.
Right.
Can you tell us what's happening?
Oh, sure. First of all, a lot of things are going on, and we'll start here at LC-41. What you see behind us, of course, is a launch pad for an Atlas rocket. This one's going to carry OSIRIS-REX. But in the future, you see that new structure for the viewers. If they look just to the right of the rocket itself, you'll see a tower that has been built for crew access exclusively. This is going to allow astronauts to go up to the top, and you'll see a little white room there off to one side of it. That's where they're going to board the rocket that'll carry them up into space. Now, that's what's going on here at LC-41. Over at what we call the C-3PF, they're actually building what Boeing calls the Starliner. This is their CST-100, used to be called that, but now it's the Starliner, and that's actually going to carry the astronaut. And so for SpaceX, right up the road in this direction, they've been modifying the old LC-39A. And what they've done is they built their horizontal integration building. They are modifying the tower. They have a crew access arm also in work that they'll be installing later this year, doing a lot of checkout. And, of course, they're modifying their cargo Dragon spacecraft and making it into a crew Dragon. And that's happening
Not even related, I think.
There's just all kinds of activity going
Just
on.
names.
I've
Again,
heard that there are
connected.
benefits with the Commercial Crew Program, both for the nation and for the International Space Station. Can you tell us a little more?
The benefits are fantastic. The journey to Mars is going to require a dedicated team. And that dedicated team can now focus on that task. They don't have to worry about getting stuff to low Earth orbit, which is where Commercial Crew comes in. We're going to enable the capability and free those folks up to worry about deep space, and we're going to worry about getting things to low Earth orbit using SpaceX and Boeing. This allows money to be spent more on the deep space stuff, which we care deeply about. We all want to get to Mars at some point. So that's the real thing. It frees up some money and also allows a dedicated team to go do that very important work.
Perfect. And my last question for you is there's a lot of talk about research. We know that these vehicles will carry a fourth astronaut who will be able to almost double the amount of time dedicated to scientific research.
Right.
What does that mean for our journey to Mars?
Oh, that's going to enable us to learn so much more. Like you were indicating, right now up on the station, they spend a lot of their time doing maintenance and things like that have to happen. When we can get these folks carrying up 4 at a time, you're going to get more research.
Well, that's all we have here at the pad. Back to you.
Thank you, Stephanie. Just under 20 minutes and counting on the T-minus clock. And again, about just under 35 minutes away from liftoff today, when you account for the planned built-in hold. Some facts and figures. Lockheed Martin Space Systems Company built the OSIRIS-REX spacecraft at its facility near Denver. The spacecraft is 20.25 feet long with the solar arrays deployed, 8 feet wide, 10.33 feet tall. The Tex and robot arm is 11 feet long.
That's what touches the
Unfueled,
asteroid.
the spacecraft is 1,940 pounds, and fully fueled as it is today, 4,650 pounds. The 2 solar array panels will be generating between 1,226 watts and 3,000 watts, depending upon the spacecraft's distance from the sun, to make its long trek over 7 years, a round trip to the asteroid Bennu and back. This is Atlas Launch Control.
So guys, I have to mention, that looks like a news thing, like you're watching news broadcasts and coming up. Oh yes.
Minus 18 minutes.
How's that coming up now?
RD-180 transducer converter calibration is complete.
Roger.
Atlas Launch Control at T-minus 17 minutes, 4 seconds, and counting. As we mentioned earlier, the crowds are gathering for today's launch. Crowds are gathering at the Launch Complex 39 gantry. Among the 8,000 guests watching launch today of the Atlas V rocket and OSIRIS-REX. Also at the NASA Causeway, members of the news media, social media, and other invited guests are watching launch. It's always a good day to watch a rocket launch, and the crowds have come out in good numbers today. As mentioned, the weather is cooperative today. When we last heard from 45th Space Wing Launch Weather Officer Clay Flynn, we have a 90% chance of favorable weather. We'll be standing by for another update from him momentarily as he briefs the launch team on current conditions in the forecast for the remainder of the launch window. Once again, you're looking at an expected condition, gaseous oxygen venting away from the spacecraft as all the fueling operations have gone well. The Centaur rocket fueled by liquid oxygen and liquid hydrogen, and the first stage Atlas booster by RP-1, a refined kerosene along with liquid oxygen. Set to generate about 1.2 million pounds of thrust when coupled with the single solid rocket booster at the time of liftoff today. And we're standing by for the weather briefing from 45th Weather Squadron Officer Clay Flynn.
I'm wondering if during the launch, anytime we get to see a Slick 40.
LWO,
I think it's Slick 40. The one that SpaceX used. Thing used as the pad is in unusable condition.
Standing by. Get ready for weather brief. LD. NLM.
ALM.
LWO, proceed. Yes, sir, this is LWO. There's been no change in the weather forecast. Probability of violation remains at 10%. All LCCs are go and expected to remain go through the balance of the count and the window. For reference, there's a small shower approximately 25 miles east-northeast of the pad. East-northeast of the pad, it would be over the pad at approximately 0015 if it holds together, but likely will be below criteria for any violation. This concludes the weather brief. Pending any questions?
RC, no question. LD, no questions. Thank you. ALM, no questions. Thank you, Alan.
Yes, sir.
So everything is still the same. Everything is go for the launch.
So once again, a very favorable weather forecast for the launch today of the OSIRIS-REX spacecraft atop the Atlas V rocket. Probability of violation is what POV stands for. That's only 10%. So as we like to say, we're 90% go. The only concern is cumulus clouds. Cumulus clouds can trigger lightning when a rocket passes within their proximity, which would not be something we would want to do. But it looks like it's a beautiful day today. The sky is clear, just some scattered cumulus, and as Weather Officer Clay Flynn indicated, some showers, but they're away from the area, and by the time that they might reach the launch pad, we should already have lifted off.
So everything is go. There's no technical issues,
T-minus
there's no weather
13 minutes,
issues.
3 seconds and counting, about 28 minutes away from launch today. This is Atlas Launch Control for Space Flight Center in Greenbelt, Maryland, and we're pleased once again to be joined by Sarah Schlieder to fill us in a little bit more about it. Sarah?
Hi there, we're back at the Goddard Visitor Center in Greenbelt, Maryland, and I'm joined by Dr. Lucy McFadden, NASA planetary scientist. Lucy, how are you doing this evening?
Fine, thanks, Sarah. It's great to be here. It's exciting.
Tell me, how excited are you for this mission?
Well, I know how everyone's heart is beating and racing down at Cape Canaveral, and I'm just so excited for them. And we're coming into the countdown, and I just can't wait to watch this bird take off.
And as you can see behind me, our visitor center is filling up very fast. Can you tell me a little bit about the excitement in the room?
Oh yeah, well, it's great that everyone's coming out at the dinner hour of the first week of school, and they're taking a break and coming out to watch this with us and to be part of the OSIRIS-REX mission. I'm really excited to see so many people here.
It's very, very exciting indeed. Now, Goddard has played a special role in this mission from the very beginning. Can you tell me a little bit about what Goddard has done?
Yeah, well, Goddard has overall management responsibility for the OSIRIS-REX mission, and one of the instruments was built here, and we have also done safety and mission assurance. So many of our Goddard colleagues are participating, and we have scientists here too who will be studying the sample when it gets back from Bennu.
Can you tell me a little bit more about that? How our scientists will be studying that sample when it comes back?
In 2023, after the sample lands back on Earth, we have our scientists in the astrobiology lab who will be studying and looking for the amino acids and the organic components that make up the building blocks of life. And so they will be finding the fragments from the components that seeded life here on Earth. And we're really looking forward to that. They've got great lab facilities. They've been preparing for this, developing their contamination procedures, and so they're really excited and ready for this.
Definitely, definitely. Now, what specific things are we going to be looking for in those samples? I know you mentioned the amino acids and...
Right. Well, the building blocks of life are the carbon compounds. And carbons can form very simple elements, but then they keep growing in different chains and different structures to grow into amino acids and then the proteins and then the processes that bring us the building blocks of life.
Definitely, definitely. Now, and is that one of the reasons that we chose Bennu as our asteroid of choice?
Yeah, well, Bennu is close to the Earth. It's accessible. It is of the right size so that we can go and touch and go and pick up a sample and bring it back without contaminating it. And it has the right composition because it's carbon rich, it's dark, and contains a lot of the compounds that we're looking for and that will allow us to piece together the process from organic materials into something that creates living life as we know it today.
Definitely. Well, OSIRIS-REX will be launching very soon, and we are looking forward to seeing it lift off. So thank you, Lucy.
No, thank you. Let's go watch it and not miss the launch.
Yeah, it's going to be difficult.
Okay.
Thank you both. Minutes.
Lots of excitement around the country as we are standing by for the liftoff of OSIRIS-REX in a little bit under 23 minutes from now. This is Atlas Launch Control.
Hold on, what? So 2 minutes, 5 hours and 20 minutes.
SYS start radar stat acquisition.
Or is that
Roger. Atlas Launch Control. We are at T-minus 5 minutes and counting.
Oh, so maybe he meant to say 5 minutes? He said 5 hours. Is that meant to be like acquisition of signal at Canberra, for example?
Counting down toward our last planned built-in hold at T-minus 4 minutes. It's a 15-minute hold, during which time all the systems will be checked, a number of polls will be conducted, and given the current condition, we expect that we will come out of the hold and count down toward launch at 7:05 p.m. Eastern Time.
I'm going to keep the video active for 20 seconds until the hold.
Here at Launch Complex 39, crowds are gathering in anticipation of liftoff of the Atlas V rocket and OSIRIS-REX. And we're standing by to go into our hold.
Program 15-minute hold.
And we're in the hold.
And we're in our
vehicle.
Hold at T-minus 4 minutes. It's a planned 15-minute hold. Launch minus 17 minutes and counting.
17 minutes until launch.
4 minutes.
I think the Space Expo is actually
Terminal count readiness poll will be conducted. One of several polls that will be held during this hold.
Come on, Internet, don't fail me now.
Looking at the Atlas rocket on Space Launch Complex 41. The rocket is 189 feet tall, about 19 stories, and weighs more than 700,000 pounds fully fueled. And with the combination of the RD-180 engine and the strap-on solid rocket booster, the Atlas will lift off, courtesy of 1.2 million pounds of thrust at 7:05 p.m. Eastern Time. Control at T-minus 4 minutes and holding. And if you're just joining us, we're just under 15 minutes away from launch as managers assess the health of the Atlas V rocket and spacecraft during this planned 15-minute hold. No technical issues of note are being worked. Weather is 90% go, and crystal clear skies seem to ensure that we will not have an issue with the weather today. During this hold, NASA Mission Manager Rex Engelhardt, OSIRIS-REX Spacecraft Mission Director Mike Donnelly, NASA Launch Manager Tim Dunn, United Launch Alliance Launch Director Bill Cullen, and United Launch Alliance Launch Conductor Scott Barney will be pulling their teams of engineers across the country, culminating in the decision to release the hold at 7:01 p.m. for an on-time launch at 7:05 p.m. The issue should crop up, the hold could be extended. The launch window this evening lasts an hour and 55 minutes, so we could launch as late as 9 p.m. But again, everything is proceeding normally at this time.
Yep, so everything is going well.
And we expect an on-time liftoff at 7:05 p.m. Eastern.
Okay.
This is NASA's first mission to take a sample from an asteroid and return it to Earth. The OSIRIS-REX mission will help scientists investigate how planets formed and how life began, as well as improve our understanding of asteroids that could maybe one day impact Earth.
Terminal count readiness poll is coming up.
This is traveling to the near-Earth asteroid Bennu, where it will bring a sample back to Earth for study as part of NASA's quest to study our solar system and beyond.
Okay.
And we're standing by for the first of our launch polls.
So that basically is go or no go. So the teams will say, right, say propulsion is go for launch. The guidance is go for launch. And I'm not sure what all. There's probably like payload, so OSIRIS-REX. There's a rocket itself. As I said, Atlas, like the lower stage, the center, which is the upper stage. I said guidance, prop. I'm thinking of what else there is. I'm pretty sure fueling is one of them. Okay, you can actually see the locks kind of venting there, the liquid oxygen, which is turning into a gas, but that's still considerably colder than the air around it when it leaves the rocket. I'm not sure what temperature exactly oxygen is liquid at, but I think that's...
NASA launch manager Tim Dunn conducting a poll.
Really? Yes? I can't hear it.
His team is go for launch.
Right, so that team's go for launch.
Listen to the various audio circuits where managers will be conducting their polls, culminating in a final go-no-go poll as we approach the end of our hold at about 5 minutes away from launch.
Okay, so
this is Atlas Launch Control.
Right, so I think what's going to happen is they're going to do the, like, each individual team is going to do the go-no-go poll, and then we'll only be able to hear the final go-no-go poll. So yeah, I'll pause the video until something happens.
T-minus 10 minutes, 27 seconds, and counting.
Wait, oh yeah, so that's L minus.
A little bit more than 10 minutes, OSIRIS-REX begins a 7-year journey, reaching its asteroid target Bennu
when returning to
in 2018. And after a survey of the asteroid to characterize it and locate the most promising site, OSIRIS-REX will collect a sample with its robotic arm and return it to Earth via a detachable capsule that will parachute to Earth in 2023.
Anytime after the terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold.
I think this is only the second interplanetary mission I've seen launch. The first one being ExoMars.
L minus 9 minutes, 30 seconds.
NSC, LC Net 1.
NSC.
Spacecraft to internal power.
Roger.
NASA spacecraft coordinator Brett Perkins asked to transfer OSIRIS-REX to internal power.
Enable position.
SRB ignition enable.
Verify FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
Redline monitor and event table are in the correct configuration for terminal count. Roger. Flight control, perform launch on time verification.
Roger.
Is 8 minutes, 35 seconds and counting.
L minus.
Everything remains go.
Launch on time verified.
Roger. RC verifies solar radiation acceptable for launch.
Verified.
LC switch to ready position. All steps are complete prior to the status check.
Okay, so that means they're about to start the go-no-go poll.
And NASA spacecraft coordinator Brett Perkins confirms that the OSIRIS-REX spacecraft is on internal power, key milestone leading toward launch today. We're at T-minus 4 minutes and launch minus 7 minutes, 16 seconds and counting.
Awesome. I would suggest reading George Orwell's 1984.
So far, no issues. Everyone continues to be go.
Not sponsored by
Status
anybody.
check to proceed with terminal count. Atlas systems propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Gas.
Go.
Electrical systems airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
COM.
Go.
Timer.
Go.
GCQ.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor. Go. Quality.
Go.
Op safety manager.
Go.
ULA safety officer. Vehicle System Engineer.
Go.
Anomaly Chief.
AC is go.
Range Coordinator.
Clear to proceed.
Launch Director.
LD is go, and you have permission to launch.
Great.
Proceeding with the count. Timer T0 is planned for 23:05 Zulu. Set count to start at 23:01 Zulu.
It should be starting extremely short.
T0 is set for 23:05 Zulu. Count will start at 23:01 Zulu.
Launch polling is complete, and we have a go for launch in 5 minutes, 37 seconds. We're about a minute and 30 seconds away from coming out of our T-minus 4-minute hold.
See that one?
NSC.
Verify spacecraft is on internal power.
OSIRIS-REX is on internal power.
All steps are complete prior to terminal count.
And once again, as you heard, OSIRIS-REX is on internal power. Launch minus 5 minutes. 1 minute away from coming out of our hold.
It's probably still going to take about another minute, maybe, until the count resumes. This, oh, hang on now. I'm just judging my time based on my watch, which is basically set to the
From now
time I
until
use, so
launch,
it's
you'll
not
be
gonna
listening to launch conductor Scott Barney and his team performing the final steps in the countdown procedure. You'll hear the team securing Atlas liquid oxygen topping, followed by the call to transfer the Atlas
On my
and Centaur
mark,
stages.
T-minus 4 minutes and counting. 2, 1, mark.
And we're at T-minus 4
counting again.
minutes and counting. Atlas and Centaur stages will be transferred from ground facility power to internal battery. At T-minus 1 minute 55 seconds, the team will command the ground launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activity.
T-minus 3 minutes and 21 seconds. And counting.
T-minus 3 minutes and counting. A brief look at the Mission Director Center in the Atlas Spacecraft Operations Center.
I'm excited. But seriously, I don't know why every now and then I do this. Quite often it's involuntary.
And the Launch Control Center. Flight termination system is on internal. Everything is going by the timeline. Standing by to transfer the Atlas power to internal and the Centaur power to internal in about 25 seconds. Once again, crowds gathered expectantly awaiting today's launch, a little more than 2 minutes away.
Yep. T-minus 2 minutes.
2 minutes and counting.
1 minute 59. Vehicle internal. 155.
Bot sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch enabled.
137.
Flight control system is to launch enable.
FTS armed.
In the final minute, the Atlas tanks will be verified at flight pressure, followed with verification of the Centaur tank pressures. 1 minute, 21 seconds and counting.
OCU's armed.
SCS count started.
115. 110.
Send out clock.
T-minus 1 minute, and counting.
Range green.
Good. No
Issues
boats.
with the range. Everything continues to be go. The final status check
Dude,
of
it's
Atlas,
50
Centaur,
seconds.
and OSIRIS-REX readiness will be conducted 25 seconds away from launch. T-minus 40 seconds.
Listen, those people are recording videos in portrait. Never record videos in portrait. Or maybe they were taking photos. If they were taking photos, it's fine.
28. 25.
Status check.
Go Atlas.
Go Centaur.
Go OSIRIS-REX.
More go.
Everyone is go. Standing by for launch. After liftoff, you'll hear the voice of United Launch Alliance's Marty Malinowski providing launch vehicle ascent data.
I'm
10
excited.
seconds. 9, 8,
Worth
7,
saying it.
6,
5, 4,
3,
2,
2, 1.
RD-180 ignition, and liftoff of the Atlas V carrying Atlas V.
Your mission to boldly go to the asteroid Bennu and back.
Oh my.
Firing look good.
Yep, it's, you can also see it's kind of slightly doing a power slide off the pad, as Scott Manley said. You can see, though, it's leaning more than usual because of that singular SRB.
Yaw maneuver to steer to its planned path, 28.5 degrees inclination from the equator.
SRB chamber pressure is almost plateaued at this point. RD-180 injector pressures are good.
Oh, that looks so hot.
45 seconds into flight.
Whole program is complete. Boosters throttled down.
And the Atlas rocket carrying OSIRIS-REX has gone supersonic.
You can actually just about see the shot.
Standing by to pass through max Q, maximum aerodynamic pressure.
That's what I...
Vehicle body rates continue to look good.
This is the point when the mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by the Earth's atmosphere.
See the RD-180 and the booster there, burning away. The next milestone, I believe, was going to be booster separation. Booster, I'm talking about the SRB, of course.
Signatures look good. Current altitude is 14 miles. Downrange distance is 9 miles. Current velocity 2,488 miles per hour. Range track shows
that's fast.
Vehicle progressing down the middle of the range.
In about 30 seconds, the
Pump
single
speed.
solid rocket booster will be jettisoned at 2 minutes 19 seconds.
And booster has throttled back down. It's now 50% of its liftoff weight.
Yeah. It's already used up half of its...
Next
It only
major
was
event
half as
will
much
be
as it weighed at
jettison.
takeoff.
Coming up
Takeoff,
momentarily.
liftoff. And SRB-7.
And you see the solid rocket booster jettison.
Separation looks good.
You can see
Vehicle has enabled closed loop Q alpha steering.
closed loop steering means
RD-180
the
engine
vehicle
continues
takes its information
powering
that
the
it knows,
Atlas,
like
Centaur,
how
and
fast it's going
OSIRIS-REX
at its
into
altitude.
space.
And it's
Next major milestone will be
adjusting
booster
itself.
engine cutoff. 4 minutes and 2 seconds into flight.
Has been fired. That system is now pressurizing to flight level. Signatures look good. Current altitude 40 miles. Downrange distance 75 miles. Current velocity 5,988 miles per hour. Range track looks good.
About 1 minute away from Atlas booster engine cutoff.
Already burn well. Pump speeds, injector pressures within band. Vehicle body rates look good. Vehicle is now 1/4 of its liftoff weight. Coming up on our 5G throttle segment momentarily. And we have begun throttling to maintain 5Gs. Signatures look good. Boost phase cooldown is underway. And begun to throttle to 4.6 Gs in preparation for BECO. Boost phase cooldown is complete. And we have BECO. Engine shutdown looks good.
Booster engine cutoff confirmed.
States
Standing
up.
by
States up. And
after
Centaur ignition.
separation for the Centaur single RL-10C engine to ignite.
There you go. I think that was ignition.
Yeah, ignition.
That's definitely ignition.
And full thrust on the RL-10.
There we go. I think this is a slightly different camera position than usual.
Everything continuing normally. A Centaur engine producing 22,900
You can see the
pounds of
fairings
thrust,
falling away there.
and it will burn for just over 8 minutes.
It's quite a long burn, but however it is a cryogenic engine.
Good. The steering has been enabled.
And the payload fairing, which was covering OSIRIS-REX, was jettisoned. Everything continuing on the timeline.
Current altitude for Centaur is 101 miles. Downrange distance is 471 miles. Current velocity 12,589 miles per hour. We do have a report from the booster performance, and it is basically nominal. Centaur PU is currently on the Oxford stop. Chamber pressures look good. Box pump discharge, fuel venturi, and pump speeds all are good.
Six minutes into the flight of OSIRIS-REX.
RL-10 continues to perform well. Chamber pressures, box pump discharge, and fuel venturi all within expected range. Centaur PU has come off the Oxford stop. Body rates controlling down the middle.
About 6 minutes left in the burn of the Centaur engine.
RL-10.
Battery voltages all are stable at this point. Tank pressures look good. And we have had the format change. Very minor loss of data during that. We're seeing our normal thermal conditioning firings on the RCS. Line temperatures have nearly warmed to bottle temperatures at this point.
Once again, you're hearing the voice of United Launch Alliance Marty Malinowski calling the ascent of the vehicle.
Still making good progress down the middle of the range. And Centaur has begun RAN steering at this point. Current altitude 139 miles, downrange distance 1,008 miles, current velocity 13,783 miles per hour.
Vehicle performed a bit of a change in attitude there. Not sure why that was performed. Probably some kind of adjusting the orbital inclination.
And the RL-10 continues to perform well. Chamber pressures, box pump discharge, and venturi all where we would expect for the ZMR. Centaur body rate still controlling down the middle.
About 4 minutes remaining in the burn of the Centaur engine.
So that's the current location of OSIRIS-REX.
Centaur
spacecraft traversing out over the Atlantic Ocean.
distance.
It's traveled that much in approximately 10 minutes.
28.5 degree inclination from the equator.
Range track again continues to show good progress downrange.
There's Kourou there, down there, I think. I think that's Kourou, or maybe is that says Galileo Station.
Centaur PU has worked off most of the oxidizer air at this point.
Okay, no, I don't remember the name of that tracking station.
Chamber pressures, box pump discharge, and fuel venturi again all.
It's accelerating at 29 feet per minute. That's approximately 10 meters per second. Per second acceleration.
Centaur continues to perform well. Current altitude 145 miles. Downrange distance 1,597 miles. Current velocity 15,333 miles per hour.
Just a little over 10 minutes since launch, and everything continues to go well.
We are approaching main engine cutoff 1. There's mission control.
Approximately 2 minutes remain in this first burn. All Centaur systems look good. Continues to look excellent. OSIRIS controlling down the middle.
My current altitude of the vehicle's
first burn.
So the vehicle is actually descending slightly. Velocity going flight doesn't. They're not giving us apogee and perigee readings. But I think the apogee is still, not the apogee, the perigee is still low. And there goes that. Wait, no, there's the perigee altitude.
Standing by for the second stage Centaur engine cutoff.
So the perigee is about to go positive.
2,143 miles. Current velocity 16,942 miles per hour.
Well, how does that work?
MECO 1 coming up in about 10 seconds.
That's the current location of the vehicle. Because there is what? There we go. Perigee
and we have IAP vanish. Centaur is now orbital.
Not quite yet, man. According to this. Now it's technically orbital.
And we have MECO. Engine shutdown looks good.
MECO is confirmed.
Safety flight termination.
There is MECO. Perigee after 89 miles. Okay, so I think that's good. 60 miles is the Kármán line, I think. I'm not sure. I know it's 100 kilometers.
Another Centaur burn will follow after about a 22.5-minute coast period. That burn is scheduled for 33 minutes, 48 seconds mission elapsed time, or about 7:38 p.m. Eastern Time. As the journey continues to
this coast phase is scheduled
put OSIRIS-REX into its planned location in space.
Followed by a second burn of 407 seconds, and a final coast-to-spacecraft separation of 15 minutes.
Here's a pause video and I'll see you then.
Fresh leader. Sarah?
Congratulations to the entire OSIRIS-REX team on a successful launch. It was an amazing sight to see, and congratulations to you, Jim.
Go OS!
Now tell me, now that we've launched, what are our scientists and engineers going to be doing over the next couple days?
They will be excitedly partying once we get on the way to the asteroid in about 15 to 20 minutes. We have our second firing off to Bennu. You know, they said, some people say this is better than Beyonce, and this is Bennu. And so that's where we're going. So they'll be real excited and getting ready for the long haul as we travel out to the asteroid over the next 2 years.
Definitely, definitely. What was it like watching that launch?
Oh my God, it was great. The best cameras I've ever seen. We had rocket cams on rocket cams, and the kids wandering around dancing. I mean, this is the future of spaceflight, going there vicariously with our Voyagers, and the excitement's palpable. I mean, I think our hearts are in our sleeves and whatever, but we're there.
And what does a mission like this mean to the next generation?
Well, this one especially, Sarah, is so important because it's going to bring something back. Not just lots of bits of data, but it's bringing back substances that we don't even know how to study right yet. But those young girls and boys of today in elementary school will invent the new tools to pick apart those samples, the way that we've picked apart the relics of the past here on Earth in modern generations. So this will be a gift that keeps on giving. And OSIRIS-REX, is going to give us that. That's magical.
Definitely. So what is the next milestone for OSIRIS-REX?
So in a few minutes, I guess 10 or 15, I have to check my watch, we will restart the big Centaur engine. That's that big, powerful liquid oxygen hydrogen engine that will give us the push off to the asteroid. We'll do a trans-Bennu injection. And that will power us to the point where we'll catch up with Bennu. But on the way, we'll sling around Earth and get a gravity assist in about a year. So we arrive in late August of 2018. First pictures, mid-August, I guess, we'll see this black dot in space. And that's where we'll be living for 2 years as we get ready to sample that wonderful place. So a lot happening in the next 2 years as we get ready for the science treasure trove.
Definitely, and I don't think the excitement is going to die down anytime soon.
But science never sleeps.
No.
Trust me, Dante will be up for the next 2 years.
Yeah. Well, it was very exciting to watch again, and again, we're looking forward to seeing all of the incredible images that we're going to get back from Bennu. I know the spacecraft is equipped with at least 3 cameras that are going to be documenting everything along the way, and it's just going to be a really incredible sight.
Well, we have 3 cameras plus a tag camera plus 3 laser altimeters, 2 spectrometers. I mean, this is bristling with instruments. It's like you just went to your medical doctor at a hospital, but we're doing it to an asteroid. So I don't think we've seen anything yet.
Right.
Just wait.
So Bennu and OSIRIS-REX are not going to be out of the limelight anytime soon. All right.
Be there, 2018.
Definitely, definitely. And what kind of documentation and imagery are we going to be getting along the way when we come back from the asteroid?
Well, once we get there, we'll start a series of lowering and lowering orbits to eventually, as we get ready to do those touch and taste high-five sampling maneuvers, the tag SAM, as the team calls it, we'll be only 10 feet above the asteroid. But we'll be doing a lot of mapping at a couple of miles above the asteroid. We'll have maps of the asteroid better than Google Earth of any place on this planet in different wavelengths. It's going to be staggering. And all that data will come right back. And the scientists here, across the team, Arizona, Goddard, Canada, will be just gushing with enthusiasm over it as they plan where to sample, because that's the next big thing. We have to figure out, what do we want to bring back? We've got this whole asteroid to figure out. So get ready. We haven't seen anything yet.
What are we looking for in a sample site?
Well, we're looking for enough debris where we can get small pebble-like chips, maybe the size of BBs or little ice chips. They won't be ice. We want that friable material to suck it into that sample capsule. We'd like to have some fine pulverized material, but the more big pieces we can get, the better they'll be to actually sample things that could contain the carbon, those carbon molecules we want to see so badly, because this asteroid has them. We know it. We just got to find them.
Right. Definitely. But nothing rocky, but nothing too smooth either.
Right.
We're really looking for that Goldilocks spot right on
small
Bennu.
stuff. And this object may be a loosely bound rubble pile of bits of stuff all linked together kind of in a foam core kind of stuff. And if it is, that'd be great, and we'll be able to tell when we get there as we orbit this object and measure what it's like. And so we haven't really studied those kind of objects yet. So it's all new. It's all good.
All right. Well, thank you, Jim,
Thanks.
and congratulations once again, and congratulations to the
Go
OSIRIS-REX
OREX.
team.
Great job. Thank you very much, Sarah. Thank you, Jim. Lots of excitement continues. We are about 5 minutes away from the restart of the Centaur engine to deliver OSIRIS-REX on its way to begin the 7-year mission. We'll rejoin now the voice of Marty Malinowski from United Launch Alliance to provide vehicle ascent data as the Centaur engine is in its coast phase. Spacecraft attached to the Centaur rocket making their way across the African continent. From Cape Canaveral, Florida to Africa in 30 minutes, 45 seconds. Away from the restart of the Centaur second stage engine, scheduled for 33 minutes and 48 seconds after launch. You're looking at real-time telemetry-driven animation showing thrusters firing on the Centaur spacecraft to steer the rocket in the proper direction.
For the MES-2 start sequence, Centaur has gone to full 100% settling on the 4S motors. Signatures look good.
Marty Malinowski describing the upcoming MES-2 burn, standing for Centaur main engine start 2. This will be about a 6-minute, 50-second burn, commencing a little under a minute from now.
And Centaur has begun the solar vector roll bias.
Or the barbecue roll.
This second burn of Centaur is scheduled for 407 seconds in duration. We are still settling at 100% 4S motors, still forming the solar vector roll at this point in time. Centaur has completed its solar vector roll. Still settling at 100% on the 4S motors. Under 2 minutes to mess. And Centaur tank pressurization is underway for the second burn. One minute to mess. Centaur has gone to dual branch fuel pressurization. Fuel pre-start is underway. LOX pre-start has begun. We have the first bypass cycle and ignition and full thrust. Chamber pressure looks good.
And the Centaur second stage engine burn, MES 2, is underway.
In response to the start transient, Centaur EU is running the oxidizer stop at this point. Chamber pressures look good. LOX pump discharge, fuel venturi, all within expected band. RCS line temperatures continue to remain at bottle temperatures. Foliage pressures in both tanks look good. Storage bottles do as well. RL10 continues to perform well. Chamber pressures look good. Controlling near nominal MR at this point. Vehicle body rates are controlling down the middle as well. Tank pressures are stable.
The Centaur burn still scheduled to be 6-minute 50-second burn with an expected cutoff about 44 minutes after launch, about 5 minutes from now.
RL10 continues to perform well, still controlling near nominal MR. All signatures look good at this point. Current altitude 104 miles, downrange distance 9,657 miles, current velocity 19,854 miles per hour.
Tracking data showing the location of the OSIRIS-REX spacecraft.
Centaur systems continue to perform well. continuing to see our thermal conditioning firings on the reaction control system. Line temperatures again have warmed towards bottle temperatures. All that is stable. RL10 continues to perform very well. All Centaur systems continue to look good as we accelerate at 1.2 Gs.
Just about 2 minutes away from the expected Centaur main engine cutoff number 2, and based on the ignition time.
MR, RL10 chamber pressures, box pump discharge, fuel venturi, all look good.
Everything continues to be normal. Managers predicted that some of the real-time start and stop engine ignitions and other events could change based on the performance, and everything continues to be normal. But based on the current Centaur main engine start, we're predicting a cutoff at about 44 minutes after launch.
Approximately 1 minute remaining in this burn. All Centaur systems continue to look very good. So we're at 1.6 Gs. RL10 chamber pressures, LOX pump discharge, venturi all good for the nominal MR. Centaur continues to look very good. RL10 performance is good. RCS continues to show typical thermal control firings. Line temperatures are good. Tank pressures are stable. Expecting MECO momentarily. And we have MECO. Engine shutdown looks good. We have 4S settling on. We have begun the turn to the PTC attitude.
Main engine cutoff number 2 occurred about 44 minutes after launch. Another coast phase is underway. This one expected to be about 15 minutes, targeting the new spacecraft separation time at approximately 8:04 p.m. Eastern Time. Deep Space Network sites run by NASA will acquire the spacecraft and gauge its health. So far, everything has gone perfectly to plan.
For spacecraft SEP.
And as we stand by for spacecraft separation, we have a video to teach us even more about what will happen with the sample once it is retrieved and returned to Earth.
My name is Jason Dworkin. I'm the director of Origin and Evolution of Life on the Earth and other bodies in the solar system from the perspective of understanding simple organic chemistry. We don't understand what happened in the ancient Earth. Most of that record is lost by subduction and other geochemical processes. However, meteorites and the asteroid Bennu witnessed the chemistry of the early solar system. A problem with studying meteorites is that they invariably land on the ground. They land in ice in Antarctica, for example, or in dirt or soil, and life very rapidly contaminates these samples. By going to collect the samples from an asteroid, we can keep the samples pristine by having very tight controls over what the spacecraft is made out of and how it's returned and archived and distributed around the world. OSIRIS-REX is a NASA mission which launches in 2016 and goes to the near-Earth asteroid Bennu, which is a organic-rich, very dark, primitive asteroid. Orbits the asteroid for about a year, studies it in great detail, and then collects a sample and returns it to the Earth for worldwide distribution and study. Samples from Bennu return to Earth in 2023. They land at the UTTR facility in Utah, then are transported to the Johnson Space Center in Houston. Any scientist in the world can write a proposal to request some sample and justify what they'll get from it. The Bennu samples will contain riches which can be studied today and are in many ways beyond technology right now to study. For example, in this laboratory, we've been studying samples brought back by the Apollo missions. The analysis is being performed by a woman who was not born yet when the samples were returned, using instrumentation that was not designed, asking questions not thought possible. This is the value of sample return. It's a gift to the Earth that keeps giving generation after generation as technology is advanced and as new people come up with new questions that we're not smart enough now to think about.
After a successful liftoff from Space Launch Complex 41 in Florida, we're less than a minute away from the deploy of the OSIRIS-REX spacecraft into space.
Centaur has begun the transverse spin-up.
Standing by for spacecraft separation.
And we have indication of spacecraft separation.
Come on, this chest. There, spacecraft up, you can see.
And as the spacecraft soared high above the western tip of Australia, OSIRIS-REX has reached Earth escape velocity of more than 22,000 miles per hour and is flying free, on its way to a 7-year mission to rendezvous with the asteroid Bennu and return a sample to Earth.
So as I went in the video here, that was the launch of OSIRIS-REX on button 25.